Hi, how's it going? I want to give you a brand new welcome to this webinar about shader graphs in Salud from Florida or wherever you are connecting in American Latina or in United States. So today we're going to practice about shaders and how to create our own effects from the point of view of the most basic point of view. It's about shaders and programming or creating them, and it can get complex, but we want to teach it in one session. So we're gonna give it a try. But this is going forward. So keep going, keep investigating, finding out more, and maintaining ourselves actualized about this subject. If you want to find me more, you can find me on Twitter, and my focus, actualized, is about operating solutions, looking for all these solutions for video games that allow you to operate for many platforms. From a video game perspective, so we do solutions for content delivery, but we have a lot of passion for graphic design, so this is why I'm presenting you this. This is the agenda for today. We're gonna go through a fast pace. If you have any questions through Twitter, you can write. So we're gonna start with what this is about. This is about shader graphs. We're gonna practice script render pipelines. So this is going to what allow Unity to allow shader graphs to work in Unity. We're gonna look at a more complex shader graph to explain this. So, so what is this shader about? Well, basically, it's a tool that inside Unity, it's a package that is installed for the package manager that permits you to create shaders in a result-driven way. If you have heard about shaders, they're programs of code that are written in a language specific, C sharp for example, that is, that those shaders, they're like materials on the editor of Unity. They allow you to see things on an object. It is not as a coding, but it's not that difficult to create. But it is difficult to become as a concept and to bring final results. So I would say it's very useful. So you can see step by step of how you're developing something. In Unity, this is in the universal render pipeline, and you can find it also. If you don't know what that's about, don't worry about it, about the render pipeline, but we'll talk about it. And if you want, that you are interested in the shader graph, it's only if you wanna, use C sharp or any coding to add functionality using the coding language HL. Uh, don't worry if you don't know about it, but it's a way to work with shader graphs with all the details. So here, let's go a step back to scriptable render pipeline. So here's an explanation. So the scriptable render pipeline is it's a it's a tubing kind of from a 3D scene. It's all 3D. It can be also in a plane of 2D in a 3D environment. Anything that's 3D needs to be turned into a 2D image. And this is what the rendering pipeline is. So basically in Unity, we had a fixed pipeline That means that we would have a fluid 3D image that couldn't be changed. But in the following years, we turned to scriptable kind of render pipeline. That means that you would have step-by-step basis with coding, and then with Unity, we have positioned you to be able to extend and add your own render pipeline. If you want to start, you can go with a few of the options that we have for the high definition universal pipeline, and also the universal render pipeline. This is what we're doing maintenance for high definition render pipeline and the universal render pipeline. There's some more details to touch, but we're just going to continue. So what does a script render pipeline does? It's defined by three things. So that are very important to know. We need to know in which part we're going to, which section we're going to put our effect in. There's sometimes that we would want to have like in certain phases of the shader. Here's the calling. So what is calling? It refers to the process of that the engine to define which things in the scene will be animated. This is done using the volume of the camera and everything outside the camera that isn't seen and everything. We put it in a list to say that these objects are in this amount of volume. You might be able to see them. In general, you're not going to be able to see all objects most of the time. Most of the time, you would and knowing all the volume. The next step is after you have that, all that information of which objects need to be designed or animated, you start to draw. And here there's many things to take into account: the lights, the materials, the shadows, the objects, objects that are transparent, and many other things. In all of that, you're defined not necessarily a full image, more like a structure of data of all the variables like colors and things of that matter. So now that we have the rendering, finally, we want to post it. Continuing right now. So while you have this scene, the post-processing is more limited for performance, but that's the last part of it in post-processing for the shader. There's difference from before in Unity of the effects of post-processing, but the idea is essential. We add buffers. We're gonna add like effects like bloom, motion blur, and many types of effects. Here's a quick universal render pipeline explanation. It's a render pipeline that Unity does. It's for high detail graphics. It's about performance and all the performance and platforms that Unity reaches. It's scalable. It adds functionality on top of the code, and it goes on a low level function as well. Covers all systems. It's available for you today. We're gonna start with our first shader now. I'm gonna open Unity. We're gonna use this demo, which is called Boat Attack, which is available. It got stuck. Yeah, it's available on GitHub. Later we'll show you the link. But first we're gonna look at the first shader graph. But let's look at this yacht. Well, It has the geometry, and in the geometry we have the measurement. It has the preference of a material, which is called an interceptor. This material has internally a shader. This shader in Unity looks like all the material properties, but obviously it's a shader of all those. So what we're gonna do now, basically, to recreate this effect using a basic shader, that's something normally we wouldn't do, but we're gonna do it to show you. First, we're gonna start create shader, and we are going to use a PVR. This means that we're going to use a shader graph utilizing a technique physically based rendering. We also have illumination. If we're doing 2D, we can do sprites as well. But we're going to use PVR today. So one sec. Graph, okay. I'm going to double click. All right, here we go. So let's see what we have in the shader graph. Well, simple things. For example, we have a PVR node. The only thing that receives is values. This is what's going to design our shader. We're going to add values, which means the position of every vertex, the color of the objects, the value of of other factors, and the vertices and such factors as that. It also has values of metallics and such. Also, this is the convention of PVR. This is you know, what constitutes us the whole effect. So we have to add values to this. So we have to calculate to make those values. So here on the left hand side, a blipboard. These are properties that we can give to the shader. So we can add from other scripts or something that's pre-built. So we're gonna add color to the shader. So we're going to create a new shader called uh, it's just a color with no input, but it has output. So we're gonna connect the nodes now to metallic, which is the basic color that's going to have. It has a preview window on the bottom right. So on the shader is to color the boat with any color. And let's choose this color right here. Awesome. I'll save it. And it's gonna ask me. As you can see, it hasn't applied it yet because it hasn't asked us to use this, so we're gonna enable that. We're going to shader graph, create, new material, and that's it. It's utilizing now the shader now. So we're gonna apply it. As you can see, it's using the volume of the shader. It looks worse now, but this is our first try. Now, what do we want to do? In reality, we wanna create something with textures. Maybe we want to feed a texture so it looks like a real boat. Okay, so let's see how we can do it. First, we can get this right click, create node. We're gonna get a node now for a texture. So get any sample texture and create the node. And the output, as you can see, the output allows many things. It can offer a vector forth, the color, or each channel has individual. So we're gonna connect it to this node. So as you can see now it gives a base color. So now we're gonna apply the color to the single texture. So I can assign directly a texture as a graph, and we're gonna choose one now. A boat. So for a boat, let's see what color we would choose. Hmm. Let's see. Let's see. This looks good. This looks good. So we're gonna use this texture now. We go back, and as you can see, it's being applied, this texture now. This model already has what the UVs mapped, but physically we have to choose what color corresponds of the texture corresponds to the vertex of the to apply the texture. As you can see, it's not really that interesting. But oh wait, another thing we wanted to show you in the texture, you can't change it. It's the texture that is there. I can't assign another one. I wish I could assign another one, but I don't want the user to have to go back. So now we have to create a new property. In this case, we're gonna use a 2D texture. We're gonna assign it over here. So we can take this property and put it out here. So this node, it's gonna connect to the input of the texture, and I'm gonna close it and put a value by default of the texture that I already had, but I'm not gonna do it. I'm gonna assign it in this way. As you can see, it went back to the previous state, but here in the inspector, I can choose new texture. So now we can assign any new texture we want. But as you can see now, it's working. So this is a good solution to work with this shader technology. And now, what else can we do? So now we can apply a tint for this texture. So so we can make a selection of different colors and multiply it by the texture, the value of the texture using tint by using this color over here. So we're going to take the input and connect the nodes, and we're going to connect the texture node to this, and we're going to connect it to this first node. And now we're going to attach that color down there, a new property that's called this, and we will drag it. We're gonna erase this one, and this is the one we're gonna actually connect, this new tint. So we're gonna utilize with the inspector. We're gonna go back, and as you can see, it's multiplying the tint on the boat. The texture isn't nearly there to give this full color switch, but this allows us to preview it and see how it's going to look, as you can see in this normal map. And when there's illumination and lights, uh, it, it gives us a good idea how things are going to look. So now what's next? So for you guys, it's basically to find other operators, other nodes, adding, multiplying, putting up values, whatever you guys want to customize, to get the vertices and pixels to change colors. So that's what we need ultimately. So we want to apply which color we want to each pixel with the shader nodes. So I could show you other examples, but this is what we want to do. We're going to open another scene. Let's see. Hmm. One sec. There's some lag, please. One sec. There's just some lag, but as you can see, we loaded up the environment. So as you can see here, we have this demo, this part of this beautiful island. This has a shader. This is a cliff shader. But if you wanted to make a shader for clothes, you know, maybe, I mean for the rocks. But we can use a shader that's already available. But we have to see what's particularly good about the shader. As you can see, we have this grass in certain parts of the rock formation, and as you get closer on the water, there's like a humid kind of look. So what if the level designer wants to say that this rock would be down in the ground in such a way? Well, this part should be redesigned, and the texture as well should be redesigned as well as the grass. But as you can see, it's actualizing without us having to change those variables. As you can see, if I lower the object, it looks perfect with humidity in certain parts, and the grass is starting to disappear as well. But at a certain height, it's doing with this is the power of shader technology in Unity. This is giving us a option to redesign the effects throughout the objects within each vertex, within each detail, and that's doing with this shader, which I'm going to show you. This is more complex, but this is extremely advanced information. This is available on GitHub, and if and in the end of the day, we're feeding our the master of values, the values of what's normal, of what is in the surface of the above value. There's many other properties at stake. So we're adding values to all the properties. So this looks really complex, but this is only simple operations. As you can see, there's divide, minuses operations, many types of values. There's a lot of variables and values, but it's simpler than it looks. So this is really easy once we know what we want to achieve for the end result. So this shader, for example, I wanted to do this, this, and that. This is how you can simplify the nodes and the graphs by knowing what you want as the end result of the object or the scene. So you ask yourself, what does that mean? How do you simplify all this? What is the end result? Like, why? How would I know that? So, for example, if you look, there's many nodes, for example, around here, and this esoteric type of alignments. The effect is overall the same in overall in the whole structure. So I'm gonna go up here and one sec. There has to be an order to all this. So as you see. So we're looking, which part, for example, of the rock formation would be the grass. So let's look through here. So for example, in this variable B, if the rock formation has this type of color, then it would paint the object at a certain with a certain texture or a certain part of a different color based on the attributes of if it is or not. So as you can see, this is an example of how it would paint certain aspects of the rock using those variables. In the end, we're generating textures to cover up these certain parameters. Now we're going back to the scene, and we're gonna save and run it. Let's see what else to show you guys to move along. Here we invite you to take a look. For example, now that we know that about shaders, let's take our knowledge about this to do other things. For example, a classic concept is the effect of wind into like the palm trees and grass, for example. This is something we can also use as a shader. Now that we have the position, now that you know we only use attributes and values, but we can also use it for vertices. So we can use the GPU, the position of the vertices based on certain how close things are to each other. You know, for example, objects like boats from the trees and etc. So let's show you which parts of the pipeline. One sec, let's go through here. Project settings, click there, and go down to graphics. And we're gonna utilize this asset and the script render pipeline. And we have various forms of drawing this scene. For example, let's look at this retro effect. This goes designs throughout the whole scene with this texture and applies it to the whole scene at once. So if I use this asset that we configured, don't worry. If you don't know the difference between the assets, it's good to just test things out. So we have various ways to do the passing of the shaders across the whole scene. And you would want to play around with the options and click down there. And this is the only thing to say that at a certain point, after you draw the skybox of the map, that you would want to apply an effect throughout the whole skybox, for example. So you would get this outline, and you know you would want to apply the effect, for example, for the skybox or anything in the map. So in order to do this, you would go through these options in this order over here. There's various passes you can do, and this is what we're talking about with the pipeline, with the tubing that allows to various points in the map to apply the effects. So okay, we're gonna save, and we're gonna see other examples now. And here is, we want to show you this effect that I love for this game, super famous game that's called, you know, Fortnite. I wanted to replicate Fortnite. So this effect, when you're building this structure, if you remember, it looks like it's shaking in this way. This is some errors here and there. So because it didn't know we're gonna use this effect. So let's look for another effect. I don't know, like let's apply another effect like this. As you can see now, it's looking less disfigured. This is a shader that is very simple to do an effect like this. Now what we're doing is to remember we have the PVR node. We're editing the position of the vertices on the node, and we're changing certain simple parameters of it.
And we have this other part that basically calculates the animation of for each pixel. So first, we're going to we're gonna add the position of where the shakiness is gonna happen. So we're gonna turn this node into an object space for real reference of where it is. Because if we don't have this, then there's no sequence to where the objects are and how they can be affected. So we calculate how far this collision has from the object in there. If we're close, we practice, uh, all these various nodes and factors that are more of like how everything is gonna look rather than the position and the variables of how the object can be affected. So this is affected. So this doesn't work on not only shaders. This kind of effect works on various scripts throughout the scene. This is a script called impact. What does the script impact does, for example? It tells you a lot of the collision data of the object and certain more information about that. So we're up here and we're going to location and it tells you the value of the position of the collision of. So we have to feed that data. We have to feed that value in C sharp in the script level of things. So we're gonna go back to C sharp script, and here's the property location down here. So we're gonna click here on the set vector with collision here. We're gonna change this. We're gonna change the value here, and that's it. The other thing is, so this looks like a mechanical animation. We're using a curve of animation that Unity has built in to modify the curve of the, so you can see the intensity of how the wave happens. So maybe you can have more intensity in the beginning of the wave or less in the beginning and so forth. So once we change that, we're getting the effect situated. So let's see how this effect animates the vertices with this shader technology. So in this situation, the effect. So we're gonna click here, and as you can see, this is a 2D shader graph for sprites. So we're gonna look at this, load it up. You can utilize this to inspect how certain materials are made, and you can also grab certain effects from it. So as you can see, this person, as you can see, there's a lot of interesting stuff here. How this animation of the trees and wind is made. This is all done with shaders. There's the other things we can achieve with shaders. One sec. You can put a reflection in the water. You see down here, you can do that with shaders. So we're gonna inspect this real quick. These two shaders. This first shader here is just very similar to what we did beforehand with Fortnite example. What we do here is the same as we feed the master node that has a PVR, and here we're using a sprite. We're using a sprite actually that uses light that allows us to use for the universal render pipeline for 2D scenes, which makes it look a lot more beautiful. So we're feeding it the position, the color as well, and to know certain variables of how it's going to look, and certain other values like this effect, for example, glossiness node effect. This balance out the extremes of all this, and you can see that the vertices is a very important subject here. So we go all the way back. Here's the time of the speed of the nodes, of how it all puts together, the direction of how the tree moves. There's many types of variables here when it comes to force. The position of every vertex, it goes, it only use the x and y axes. We use another vector here, but as you can see, we have many multiplied kind of nodes. These are nodes of noise that has two inputs. These we haven't seen before, but these are all, up here are all multiplied values of all the factors. This only uses variables of integers of 0 and 1s, and you combine all this, and you get the result here. This is only possible documenting by using a script called loss script in the asset package store, and you can see it looks phenomenal. Now we're going to the water reflection shader. Just one second, I'm gonna look over here and click here. And 1 second, please. And here we have the position. We're using a certain type of noise that is the same that is used in this effect in water and other kind of scenes. It means that the light will enter the water and hit certain parts of the water and certain parts not. This is what we're utilizing for this. For this node, for the master node, we're using not a lot of color nodes, but we're using more location-based nodes of how the light would hit the water and how it would reflect and so forth. Yeah, so this is what we're using. It uses certain advanced variables for the water and that are called 1 sec. Let me see. And let's create this new node. So as you can see, this is a little bit more complex, but in the end of the day, we end up doing the same result here. So here, I do want to show you uh, render texture, this one we have here, to make the reflection happen. The reflection really is a camera that draws up that which we don't send directly to the screen, but it's rather more a texture that has a shader graph that we attach to the sprites. That's how this works. This is how it works. And we're saving, run and build, and that was the presentation on 2D sprites. And we're gonna go back here, and then here we go. That was it. Here are the links if you want to learn more about the boat attack, the lost script. It's in the asset store, and the custom lighting in shader graph if you want to know more about how to create your own animations using shaders. There are certain effects that you would need to know more about: illumination, the color of the vertices inside the shader graph, and how to integrate the lights outside the actual shader. I hope you like today's presentation. I hope it has helped you out, and we want to thank you for your time. And we would love to talk to you later, and we're glad to have this in English or Spanish. And we look forward to more meetups. And anything, if you want to reach out to me from YouTube or Twitter, look up the hashtag. We wish you a great day, and thank you very much.